Okay, so this first video is on the formation of solutions. Now, there's lots of types of solutions. I'm going to focus on aqueous solutions in which the primary solvent is water. In organic chemistry, that's what we do primarily. Organic solvents and solutions involving organic compounds tend to be much more important in organic chemistry. There are two main types of solutions we're going to talk about. One involves ionic compounds and one involves covalently bonded molecular substances. So let's start with the ionic compounds. For ionic compounds in water, the process by which dissolving occurs is called hydration sometimes, or hydrolysis. In this process, you have a water molecule, which is a polar molecule with a partial negative on the oxygen and a partial positive on the hydrogen, and you have an ionic compound, which could be a salt or a base. So maybe it could be NaCl, that's an ionic compound that is a salt, or NaOH, that is an ionic compound that is a base. And these substances consist of a crystal lattice, which means you have a positive ion or cation surrounded by anions, like so. And they form a structure with a repeating pattern in which every single cation is surrounded by anions in three-dimensional space, and every single anion is surrounded by cations in three-dimensional space. And so they're essentially sticking to each other because of the opposite charges. Now, during the process of hydration, the polar water molecules, which are moving around as you drop, let's say, a piece of salt into a beaker, will be moving around. They'll bang into this thing here, and when they do bang into it, as long as the forces of attraction between the ions are not too strong, you'll have an ionic compound that's soluble. Sometimes they're too strong and the compound does not dissolve. Not all ionic compounds are soluble, and we'll learn about solubility rules a little later after this video. When this occurs, the water molecules end up being surrounded essentially by the ions, and because opposites attract, the positive ions or the cations will be near the oxygen atom, and the negative anions will be near or to the hydrogen. So this would be like a sodium over here, and this would be a chloride over here, or this would be a sodium over here, and this would be a hydroxide on the other side. Now, unfortunately for us, aside from ionic compounds being very simple, when we deal with molecular substances, it gets a little bit more complicated. So we're going to touch on that next. So let's say you're dealing with a covalently bonded substance. For example, let's say we'll put this as B. Okay, and so now we're dealing with molecular substances. Now, the ones that tend to dissolve well in water tend to be polar molecules. Remember the whole like dissolves like thing. All right, so they might be things like sugar. Sugar is a polar molecule. It's big, C6H12O6, and the reason why it dissolves is because the sugar molecule, which is like this hexagon-y thing, right, is covered in these hydroxyls, and these hydroxyls, are polar just like water. So they have a negative part and a positive part. Because they're like water in that they are polar as well, they are attracted to the water molecules and they dissolve. The ones that really are going to be important to us in the air, though, honestly, are going to be acids. And acids are special in that when they dissolve in the water, they start as a polar molecule, but as they go into the water, they ionize. And that's different from the ionic compounds. The ionic compounds are already ions, so they don't change their charges on their particles. Just the charged particles separate. But something like HCl, which is a strong acid, when it goes into the water, it literally reacts with the water and forms H3O pluses and Cl minuses. And the key thing you want to get here is when you start, there are no ions to start. Here you have ions. And so we say when acids go into water, they ionize. Now, strong acids completely ionize. For example, any of these ones, HCl, HI, HBr, and these you have to actually know, HNO3, HClO3, HClO4. Those are chloric and perchloric acid, and sulfuric acid, which is a strange exception we'll get to later. These guys are all strong acids, and that means they completely ionize. So for every HCl that goes into the water, you get one, right? If HBr goes into the water, right, whenever you do it, if you put 10 molecules of HBr into the water, you're going to get 10 H3O pluses, and you're going to get 10 Br minuses. All right? That means you're going to get a lot of ions. And that means it's a really going to be a strong, what we call, electrolyte, just like the ionic compounds are that dissolve. If you have a weaker acid, let's say like hydrofluoric acid, right? You might have to put 10,000 molecules of hydrofluoric acid into water, okay? And during that process, you're basically going to end up with maybe one H3O plus. Now it's still an acid. You still made some ions that weren't there, right? And you're going to get one fluoride ion, okay? But because you get so few ions, and most of the HF stays in molecular form. Because of that, you have what we call a weak electrolyte. And the reason why it's a weak electrolyte is you're not producing many ions. So it's not going to conduct electricity very well. And that ends that video. We just stop there.